Okay, so in this video, we're going to go over how to graph our functions of exponential growth and decay. So in this first one, number 1, I have negative 1/2 to the x plus 1. So if we take a look at our notes from the previous day, the base, which is the number right next to our exponent, that tells us whether it's growth or decay. So if it's greater than 1, we have growth. If it's between the values 0 and 1, we have decay. So remember, b cannot be negative or 0. These are the different graphs we have. So it'll be coming in horizontally and then going up, or coming in horizontally and going down if it's growth. If it's decay, we're coming in vertically, so we're coming down or we're coming up and then ending up horizontally, which is our asymptote. So the first thing we're going to find here is our y-intercept. So we do that by setting x equal to 0. So I'll have negative 1/2 to the 0. Oh, that negative's on the outside. So I have negative 1/2 to the 0 plus 1. Okay, any number raised to the 0 power, remember, is equal to 1. So this is a negative 1 plus 1, which is equal to 0. Okay, so that's our y-intercept. Our x value is 0, then our y value is 0. So that's going to be a point right at the origin here. Next is the asymptote. So asymptote we find based on what d is. So after we have the exponent, our base with the exponent, we have plus a number or minus a number. If there's nothing here, then d is 0. But in this case, we do have 1 added. So our asymptote is going to be y equals 1. And then the domain for this, any value can go in for x. So that would be from negative infinity to positive infinity. Next, we have to decide, is this growth or decay? So I look at the b value, that's the number right next to the exponent, and it's 1/2. So 1/2 is not bigger than 1, but 1/2 is between the values 0 and 1. So it's definitely going to be decay. So I'm just going to circle decay. And now we're going to graph it. Let me grab a different colored pen. So, actually, no, I'm going to use this. So first, our asymptote, I already marked the x-intercept, the y-intercept, that's at 0, 0. And then our asymptote is at y equals 1, so I'm just going to make a little mark. So I'm using highlighter. You can use a dashed line to show that your asymptote is at y equals 1. So since it's decay, I know growth comes in horizontally, so decay is going to come in either from the top or come in from the bottom. So here I'm going to have to hit this point, and I'm going to have to be almost parallel with this asymptote. So it's not totally parallel, but I'm going to be approaching that point. So growth, we would come in horizontally and then go down, but since it's decay, we're going to be coming from the bottom and then going out horizontally. So our graph should look something like this. So decay, we come from the top or from the bottom, and here this one we're coming from the bottom because I know I have to go through this point and end up going along the asymptote. So we never go through this asymptote, we never go through that line. Okay, so that's for the first one. Next one, we're going to find the y-intercept. So again, I'm going to set x equal to 0. So I'll have 2/3, 0 minus 1. And so this will be 2/3 to the negative 1 power. Okay, so our negative exponent rule just means we flip the fraction and then it becomes a positive exponent. So this will become 3/2, and it's to the positive 1, which we don't really need to write positive 1. So this negative 1 just flipped our fraction to 3/2. So the y-intercept here is going to be 0, 3/2. And then from there, we're going to find the asymptote. So asymptote is always that number added afterwards. So not in the exponent, but next to this last digit here. So In this one we had 1/2 to the x plus 1. This one we have 2/3 to the x minus 1, but we don't have plus or minus anything. So remember that would be a plus 0 if we don't have anything. So my asymptote's going to be 0, y equals 0. Domain again, I could plug in any value for x and this graph will exist. So it will be negative infinity to positive infinity. Is it growth or decay? So I'm going to look at this number right next to the exponent, which is our base. It is 2/3. And remember, 2/3 is between 0 and 1. So it's not greater than 1. It's going to be between. So this is decay. Okay, and now to sketch it, I'm going to first plot my point for the y-intercept. These lines don't necessarily have to equal 1, 2, 3. Like, let's see, 3/2. 3/2, this could be 1. This could be 2. So 3/2 would be 1.5, so 1.5. So that's my 3/2. And then y equals 0. That's just our x-axis, so I'm just going to highlight that. Okay, so then when I go to draw this line, this function, it's going to be decay. So remember, decay, we're coming from up top or from the bottom. And I know that I'm going to end up almost parallel, not quite, approaching this yellow line. So I'm going to be coming from up here, down through that point. Okay, so I know my goal is to come through this point and end up almost parallel to this line. Okay, so with decay we start from coming from the top and then through here, or from the bottom. So since I knew I had to come through this point, I knew that I'm going to be approaching this y equals 0 from the top. Okay, next one, I have 3. Number 3, y equals 4 1/2 to the x plus 1 minus 1. Okay, so the y-intercept, we're going to plug 0 in for x. So this is 4 1/2, 0 plus 1 minus 1. Okay, so 0 plus 1 is 1. And any number to the first power is just going to be itself. So I have 4 times 1/2 minus 1. When I go to multiply here, remember 4 is over 1, and you just multiply straight across. So this will be equal to 4 over 2 minus 1, which is 2 minus 1. So my y-intercept will be equal to 1. So this will be 0, 1. My asymptote is going to be this number minus 1. So it's going to be y equals -1. My domain is going to be the same, negative infinity to positive infinity. Okay, and then is it growth or decay? So I look at this number here right next to the exponent. 1/2 is between 0 and 1, so I know that it's decay. And now sketching. So for the sketch, I'm going to first put my point in for the y-intercept at 0, 1. I have an asymptote at -1. So we'll go to -1 on the y-axis and draw a line here. Okay, and then again it's decay, so I'm going to have to come through this point and end up parallel with this. So we never go through this asymptote line. So I'm going to be coming in from the top, down, and then almost parallel, approaching y equals -1. So this is going to look like that. And I should be labeling these points. So that was 0, 1. This one up here, we have 0, 3/2. And here we had 0, 0. Okay, so just remember, sketches are going to be not exactly what the graph will look like, but it's a rough idea so we know what to picture when we see a function. This next one, again, I'm going to set x equal to 0 to find the y-intercept. So I have 18, 1/3, 0 plus 2. So that'll be 1/3 squared. So remember exponent rules. When you have a fraction raised to an exponent, that exponent is applied to the top and the bottom. So this will be 18, 1 squared is 1, and 3 squared is 9. And now I'm going to multiply what I have here. So 18 is a whole number over 1. Multiplying straight across, I end up with 18 over 9, which is equal to 2. So my y-intercept will be 0, 2. My asymptote, again, we don't look at the exponent, but I look if there's anything after, and there's nothing, so there's a plus 0. My asymptote will be y equals 0. Domain again, any value can go in for x. Okay, and then growth or decay. So looking here at my base number, 1/3 is between 0 and 1. So I know, again, we have decay. So all these problems on the front ended up being decay. So I'm going to mark my y-intercept as 0, 2, and label it. And then my asymptote at y equals 0, I'm going to highlight that line. Okay, so graphing again, it's decay, and I can't go through the asymptote. So I know I have to go through this point and end up approaching this yellow line. So it's decay, so I'm coming in from the top and approaching, and that is what it will look like about. Okay, and on the back. All right, so y-intercept again, I'm going to set my x to 0, so I have 1/3, 0 minus 1, plus 3. Okay, so this will become 4 times 1/3 to the negative 1 plus 3. And here we have our negative exponent rule again. So this negative exponent just means I'm going to flip what I have here. So this will become 4 times 3 over 1 to the 1, positive 1, plus 3. So I don't really need to write, it's to the first power, and I don't really need to write this 1 under the 3. It's just going to become a whole number 3. Multiplication before we add, so 4 times 3 is 12, plus 3, which is 15. So my y-intercept is 0, 15. My asymptote is going to be this number here, so positive 3, y equals 3. So just be careful that you're not looking at the exponent, you're looking at the number afterwards. And then the domain, again, is negative infinity, positive infinity. Is it growth or decay? So looking at my base, it's 1/3, which is between 0 and 1, so it's definitely decay. Okay, so the y-intercept 0, 15. I'm going to count these off by 5, so 5, 10, 15. I'll have a point here and call this 0, 15. Y equals 3. So if these are each 5s, it's going to be in the middle here for 3. And then it's decay. So I know I have to come through this point and end up horizontal. So I'll have to come in through here and horizontal through there. Okay, the next one. Y-intercept will have negative 9, 3 to the 0 minus 1, minus 1. Okay, so this will become negative 9 over, because 0 minus 1 is negative 1, so that'll become negative 9 over 3 to the positive 1, minus 1. Negative 9 divided by 3 is a negative 3, minus 1, which is negative 4. So my y-intercept will be 0, negative 4. My asymptote is this number that's added or subtracted at the end, so y equals negative 1. Domain's the same again. And this will be growth or decay. So here we finally have something different. So this is not between 0 and 1. 3 is greater than 1, so we have growth. So the y-intercept is 0, -4, 1, 2, 3, 4. And then I have an asymptote at -1, so I'm going to mark -1. And I'm going to label this, because I keep forgetting to label, 0, -4. Okay, so when we have growth, that means we come in horizontally. So I'm not coming in from the top or the bottom, I'm coming in horizontally, so from the asymptote. So this is going to be coming in from here and then going down, just like that. So that is our exponential growth. So see, we come in horizontally and down, where decay we come in from the top or from the bottom. All right, 4 more to go. So this one, when I find the y-intercept, will be -3 times 1/3 to the 0 minus 1, which is -1 minus 1. So here, we have our negative exponent rule again, so that's going to flip the fraction. So just be careful you follow your order of operations, right? You do parentheses first, exponents, multiply, divide, then add and subtract. So exponent here is -1, so I'll have -3 times 3 over 1 to the first power minus 1. So again, I don't need the over 1 to the first power, it's just 3. -3 times 3 is -9, so multiply next. And now we do the adding, subtracting to get -10. So my y-intercept is 0, -10. My asymptote is going to be this number here, so y equals -1. And then the domain is the same thing again. Okay, so here is it growth or decay? So this number, 1/3, it's going to be greater than 0, but less than 1. So that would be decay. Okay, so I'm going to graph it now. So I have 0, -10. So I'm going to count by 2's this time. So 2, 4, 6, 8, 10. 0, -10. My asymptote's at -1, so we'll have to go halfway between those 2 points. And then it's decay, so I'm going to be coming from, so remember decay, you come from the top or the bottom. Here I know I'm going to come from the bottom because I have to go through this point and end up being approaching this line. So here we'll come up and approach. So something like that. Right, the next one, y-intercept, we have 54 times 3 to the 0 minus 3, which is -3, minus 1. So I deal with the exponents first. So this becomes 54 over 3 to the third minus 1. 3 to the third is equal to 27 minus 1. 54 divided by 27 is 2. Minus 1 equals +1. I bet you thought that was going to come out to be a large number, but it's not. It's just 1. 0, 1. My asymptote is this number here, so again it's -1. Domain -infinity, +infinity. I could plug any number in for x and this graph will exist. Growth or decay. So I look at the number here next to the exponent and it's 3. So 3 is larger than 1, therefore it is growth. So I'm going to have a point at 0, 1 and my asymptote at -1. And then we have growth, so I'm going to come in horizontally and then go through that point. So I know I have to be on the upper part of the asymptote because I have a point above here. So I need to be parallel but never going through my asymptote and then going up through this other point. So this will be up like that. Okay, and labeling points, this would be 0, 1. All right, 2 more. All right, so here my y-intercept, I have 1/8 times 4 to the 0 plus 2 plus 3. So this will be 1 over 8 times 4 squared, which is 16, plus 3. And 16 times 1 over 8, that's like 16 over 8 when you go to multiply, plus 3. So 16 divided by 8 is 2, and 2 plus 3 is 5. So this will be 0, 5. My asymptote is plus 3, so y equals 3. The domain is negative infinity, positive infinity. Is it growth or decay? So I look at this number here raised to the exponent. So be careful. This time my a value is 1/8, not my b value. So there's a difference between these two. This is the number being raised to the exponent. So this number here is 4. It's greater than 1, where my a value is between 0 and 1, but we're not looking for that to decide if it's growth or decay. We look at this number. So since this is greater than 1, it's growth. So drawing the sketch, we have 1, 2, 3, 4, 5. And I have an asymptote at 3, 1, 2, 3. And then you come in horizontally with growth. So I'm going to come in here and then go up through that point. And let me label 0, 5. All right, and the last one, we have to find our y-intercept. So this will be -2, 1 over 5, 0 minus 1 is -1, plus 5. Okay, so this 1 over 5 is going to flip because I have a negative exponent. So this will be -2 times 5 plus 5. -2 times 5 is -10 plus 5, which is -5. My y-intercept will be 0, -5. My asymptote is this number here, y equals 5. And the domain, I can plug in any value again for x. So growth or decay, I look at this number by the exponent. It's 1/5. That is between 0 and 1. So this is decay. Okay, so now plotting my points, I have 1, 2, 3, 4, 5 is my y-intercept. And my asymptote is 1, 2, 3, 4, 5 up here. This one's going to be pretty steep. And since it's decay, we're coming in from the top or the bottom, so I'm going to be coming in from the bottom and reaching just like that. That one was a bit of a stretch. But yeah, we should never go through that asymptote, so I went through it a little bit to try to avoid that. And this is 0, -5.